Hello everybody, this is Jimmy. Today I'm going to explain the basics of relays and what they're used for. If you want to control anything that needs more than 20 milliamps or 5 volts, which is the max the Arduino can supply, a relay is a great option. Relays can control air solenoids. Here's a 24 volt one. This is a 12 volt LED strip. A really big starter motor, or AC devices. So a relay can control pretty much any household appliance you would plug in the wall, such as Christmas lights, vacuum cleaners, ovens, that kind of stuff. This is the 12 volt relay out of my car. This controls my starter motor. So anytime you start your car, guess what you're using? A relay. The way relays work is they take a small signal from an Arduino and which goes through a transistor. And that transistor opens up a bigger valve which allows water to flow through and push down on this switch, which then flows to the Arduino ground. When this switch is activated, it makes an electrical connection which allows a much bigger supply to go through. Now, unlike a transistor, the ground on the supply and the ground on the Arduino do not need to be connected together. And this is what allows you to switch AC devices and can reduce the noise that an Arduino sees. So if you're switching really disgusting water like sewage or something, relays are a really good option. So if we go ahead and connect the Arduino to our power supply, in this case I have the Blink sketch uploaded. All it does is turn pin number 13 high or low. Please see the description on where to find that. If we go ahead and hook up our relay so that the in, which is the orange wire, goes to pin 13. The 5 volt goes to Arduino 5 volts, the ground goes to ground, and then the corresponding connections on the relay. We can hear the relay start to power on. So what we're going to do is hook up a 12 volt LED strip. We'll take the common of the power supply, hook it up to the positive of the LED strip, then connect the negative to the ground of the 12 volt power supply. And then all we need to do is make a connection to connect the relay to the 12 volt. Now we have two options here. There's a normally closed and a normally open. For this relay, if we connect the normally closed, what happens is when the Arduino is powered high, so when that LED turns on, the LED strip turns on. One of the disadvantages of this and this particular relay is if the Arduino were to lose power, if we unplug it, the relay defaults on. So the way we fix this is we switch it from being normally closed to normally open. So we just switch the side that the wire is connected to. Now, when the Arduino is off, this LED strip turns on. So it's a little backwards, it's just something to be aware of, but it's pretty easy to fix in code. Now the great advantage of this is when I disconnect the Arduino, the light also turns off. So if we were doing something like a circular saw where it's really critical that you don't get your hand cut off, you would definitely want to have it, if the Arduino were to ever lose power, the circular saw would lose power as well. So this is just something to be aware of with relays, is you do have two options. The reason basically the way that works is there are two electrical posts. When this solenoid activates, it pulls this little spring down, and that spring, instead of making this connection on the top, which goes to the normally closed, which is just its default, it will make the connection when it's powered on to the normally open. So that's just the rough basics of how it works. It's pretty simple.